All right, for section 11.5, let's take a look at how to work with some formulas to begin with, how to play with them. First of all, if possible, let me get rid of fractions. Let me multiply, in this case, both by v squared. So I have the v squared times w is equal to kfr. All right, so now, first get rid of any signs like square roots. If you have any, get rid of them. Get rid of any fractions. Now let me take a look. It says solve for v. So let me get the v by itself. What I'm going to do, I'm going to divide each side by w. So I have v squared. V squared, it's kfr over w. To get the v by itself, let me get the square root on each side. And that's going to give me that v, it's either to positive or negative, the square root of kfr over the square root of w. Now, in previous sections, we learned that we cannot have a square root at the bottom. We cannot have a radical at the bottom. The way I'm going to get rid of it, I'm going to multiply top and bottom. In my fraction, I'm going to multiply top and bottom by the square root of w. So that gives me positive or negative. On the top, I have kfr w over square root of w times square root of w. That's just w. Right? We multiply by the radical to get rid of the radical sign. So that's it. So just to make this a little bit simpler, I'm just going to write the v is equal to plus or minus the square root of kfr w all over w. Let's try one more time. First of all, let me get rid of the square root sign. So the way I'm gonna get rid of it, I'm gonna square both sides. So I have d squared is equal to 4a over pi. Then let me get rid of fractions. The way I'm gonna get rid of fractions, I'm gonna multiply both sides by pi. So I have that pi d squared is equal to 4a. Now I see the instruction says solve for a. Let me divide each side by 4. So pi d squared over 4, it's equal to a. That's it. A is by itself already, so I'm just going to say a equals pi d squared over 4. Now you try some at home. That's what you guys should get. Now let's take a look at this one. All right, I don't have any square roots. I don't get rid of any square roots. I don't have fractions, so I'm good with that. I'm solving for t now. Now I see my t. Here I have a t to the second, and here I have a t to the 1. So it's not like I could factor out t. But I remembered that when I used to solve for a variable where the first one was to the second power, the second one to the x, to the 1, I had a formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, the way I'm going to solve for t is going to be that. All right, I must have one side equal to 0. So my s, let me move it over as minus s. So I have that 0 is equal to 2t squared plus kt minus s. My a in this case is 2. My b is k, and my c is negative s. All right, I got to look at the square root part first. Remember, I'm going to do my b squared minus 4ac. Then I'm going to do the square root of it. So I'm just going to go k squared minus 4 times 2 times a negative s. So I have k squared plus 8s. Have a plus sign because I had two negative signs, negative and a negative. All right, negative with another negative made it a positive sign. So I have k squared plus 8s. And I'll do the square root on it. Cannot simplify more. That's as simple as I can go. All right, so let me do the whole formula now. T equals negative b. So I'm just going to write negative k plus or minus the square root of k squared plus 8s all over 4. Right? 2 times a. Well, now a is 2, so 2 times 2 is 4. That's it. Now you guys try this one at home. That's what you guys should get. Now here, two cars left an intersection at the same time. One headed due north, so one of them was going north. The other one going west, due west. North and west, they create a 90-degree corner. My 90-degree corner, I can put a 90 degrees, or sometimes I put a box. Sometime later, they were exactly 100 miles apart. So you see my distance is 100 miles between them. The car headed north had gone 20 miles farther than the car headed west. So I'm going to say the car headed west went X many miles. The one going north went X plus 20 miles. How far had each car traveled? We're going to use a formula we call Pythagorean theorem. Pythagorean theorem is a squared plus b squared is equal to c squared. When we have a right triangle, the biggest side of all, the one that is farthest away from the 90 degrees, we're going to call that C. The other two sides, one of them is A, the other one is B. It really doesn't matter which one is which. So I'm just going to call this A, and I'm going to call this B. So what I have for my case, I have x squared plus x plus 20 squared is equal to 100. 100 squared. Now my x plus 20 squared, I'm literally going to write x plus 20 twice, because that's how I remember that I have to distribute. All right, so what I have here, I have x squared plus, all right, let me distribute the x from the first parenthesis, so that gives me x squared plus 20x. Now let me distribute the 20 from the first parenthesis, that gives me plus 20x plus 400, 100 squared, right? 100 times 100, that is 10,000. To simplify things a little, x squared plus x squared, that gives me 2x squared. 20x plus 20x, that gives me 40x plus 400 is equal to 10,000. Let me subtract 10,000. So that gives me 2x squared plus 40x minus 9,600 is equal to 0. Okay, if you can make your number smaller, by all means do so. What I'm going to do in this case, I'm going to divide everything by 2. So I'm going to have x squared plus 20x minus 4,800 I divided everything by 2 just to make my number smaller. You don't have to, but it just makes it easier. Okay, we could do quadratic formula, we could do factoring, we could do anything we want. In this case, actually, let me factor it, just so we don't forget how to factor it. Thinking two numbers that multiplied equals negative 4,800. Multiplication is negative, so that means my signs are different. And then when I add my numbers, it's equal to 20. So two numbers that multiplied equals negative 4,800, but when I add them is equal to 20, I'm thinking of 80 and negative 60. So I can factor this easily as x plus 80 x minus 60 is equal to 0. We could do quadratic formula as well. We could just plug it into a quadratic formula and then we get our solution. But here, because I'm using factoring, after I factored, I must let each of my factors equal to 0. X plus 80 is equal to 0. X minus 60 is equal to 0. So it tells me that x, remove the 80 over, x equals negative 80, or x equals positive 60. If I do quadratic formula, I'm going to get negative 80 and 60, right? I get to this point. Now let's take a look at the question. One car traveled X many miles. I look at my X negative 80. And that doesn't make sense. A car cannot travel negative miles. So that means that this car, the one going west, travels 60. Right? 60 makes sense. Now a negative doesn't. A car cannot travel negative miles. So this car travels 60 miles. The one headed north, the one that was going north, this one traveled 80 miles. The question was, how far had each car traveled? 60 and 80. Now you try this one at home. A 13-foot ladder is leaning against the house, so there's the ladder. The distance from the bottom of the ladder to the house, 7 feet less than the distance from the top of the ladder to the ground. We don't know the distance from the top of the ladder to the ground, so we call it x. The distance from the bottom to the house is 7 less, so that's why x minus 7. There's a 90-degree angle there. So for x, you should end up getting that x is equal to 12. As a matter of fact, we're going to get the x equals 12. Here, how far is the bottom of the ladder from the house? You should get 5 feet. Okay, now this one, let's work this one out. Rectangular reflecting pool in a park is 20 feet wide and 30 feet long. So I see a pool here. It is 20 feet wide and 30 feet long. The park gardener wants to plant a strip of the grass of uniform width. So that means the same width all the way around. She has enough seed to cover 336 feet square. So I can see that they're adding some grass. And the width of it is X. Okay, so let's take a look from the top. If I was to look from the top, I have a pool. This is what we mean. We have a pool, and it's 20 by 30. We're going to add some grass all the way around it. The width of it is X. So when I think of the very top, the width, the length of this is going to be 30 plus 2x. Because I have 30, but then I added x on each side, so that's why 2x. The width of it should be 20 plus 2x, right? 20 for the pool and x for each side. Now, the way we find the area of the grass, why don't we find the area of everything, which is grass and pool? So I'm going to find the area of the big rectangle. So I'm going to go 30 plus 2x times 20 plus 2x. So remember, that gives me the area of the pool and the grass. let me take away the area of the pool, which is 20 by 30. So remember, I have the area of everything minus the area of the pool. That's how I have the grass. And I know that the grass, I have enough seed to cover 336 feet square. Let me solve for x. Okay, the way I'm going to do this, let me get rid of parentheses. Let me distribute the 30. So that gives me 600 plus 60x plus 40x plus 4x squared minus 600 is equal to 336. All right, let me separate the sides of the equal sign. I'm going to combine like terms starting from the highest exponent. So the highest exponent is 4x squared. Cancel it so I know I already used it. Then 60x plus 40x, that's going to give me plus 100x. Then 600 minus 600, that's 0. So I'm just going to cancel it. 600 minus 600. This is equal to 336. Let me get the right side equal to 0. Let me move this 336 over. That's a minus 336. So I have the 4x squared plus 100x minus 336 is equal to 0. We could try factoring. We could try quadratic formula. One suggestion that I do is if your numbers can be made smaller, let's make them smaller. I see the very front I have a 4. Let me divide everything by 4. So that gives me x squared plus 25x minus 84 is equal to 0. Nice, I'm dealing with smaller numbers. For us to not forget factoring, I'm looking for two numbers that multiplied equals negative 84. So that means the signs are different because the multiplication is negative. But when I add my numbers is 25. I'm looking at 28 times 3. So the way I'm going to factor this will be x plus 28 times x minus 3 is equal to 0. I'm factoring, so I'm going to have to let each of my factors equal to 0. X plus 28 is equal to 0. Work that out. X minus 3 is equal to 0. And then work that out. So, okay, so x plus 28. Let me move the 28 over. I get x equals negative 28. X minus 3 equals 0. Let me move the 3 over. So I get x equals 3. When I look at my answers, because my question here is how wide will the strip be? I see x equals negative 28. X being a negative? Yeah, that doesn't make sense. So in this case, x equals 3. How wide will the strip be? 3 feet. Right? Simple. Now you try one, but in this case, your pool is going to be 20 by 40. Remember, mine was 20 by 30. Yours is 20 by 40. And in my case, I had the seed that I had to cover was 336. In your case, you have enough seed to cover 700 feet square. So do what I just did. You can pause this video to not see the answer. Now, how wide should the grass strip be? In your case, you're going to get 5 feet. All right, let's take a look at this type of question. If an object is propelled upward from the bottom of a 144 feet building at 112 feet per second, its position in feet above the ground is given by this formula. Okay, I underlined some numbers because the 144, the height of the building, right where it started, it's represented there. All right, so that's taken care of. The initial acceleration, 112 feet per second, It's represented here. Now, this negative 16, that's the gravity. It's negative because gravity is pulling things down. So this formula gives us the height of an object. Okay. In seconds, t is in seconds. So when I continue reading, it says where t is time in seconds after it was thrown. So that formula will give me the height of the object after t seconds, All right, when does it hit the ground? The question here it is, when does it hit the ground? Remember, the formula gives me the height of the object. I'm trying to know, when does it hit the ground? Wouldn't the height be 0? Okay, so in this case, I'm just going to go and I'm going to say 0 equals negative 16 t squared plus 112t plus 144. Solve for t. If I can make my numbers smaller, by all means do so. Let me divide everything by negative 16. Zero divided by negative 16 is 0. Negative 16 divided by negative 16 is 1t squared. 112 divided by negative 16 is negative 7. And then minus 9. Cool, I have my numbers smaller. Now here I cannot factor. Think of two numbers that multiply equals negative 9, but when you add them equals negative 7. Okay, factoring is not quite going to work here. So what I'm going to do, I'm going to use my quadratic formula. Negative b. A bad boy went to a so-called radical party. The boy was being square. He lost a chance with 4 awesome chicks. Everything was over at 2 a.m. I know my A is 1, my B is negative 7, and my C is negative 9. I'm going to do the square root part first. So B squared, negative 7 squared, minus 4 times 1 times a negative 9. All right, negative 7 squared, negative 7 times negative 7 is 49. On this other side, there's 2 negative signs, so that makes it plus. 4 times 1 times 9 is 36. Now 49 plus 36 is 85. Then I have to do the square root of 85. Just gonna, let's see, square root of 85. I get it's about 9.22. Or let's just call it 9.2. Or 9.2. I'm just gonna leave it at that. It's a longer number. All right, so let me do the quadratic formula now. Negative b. Negative of a negative is positive 7 plus or minus 9.2 all over 2. All right, 2 times 8 gives me 2. All right, so that's going to give me my t. So if I use the plus sign, 7 plus 9.2, that's 16.2. Let me divide that by 2. So I get that t is equal to 8.1. Now let me use the minus sign. 7 minus 9.2 divided by 2. I get that t is also negative 1.1. Now, the negative sign doesn't quite make sense, right? I cannot throw something and have it hit the ground before I even throw it. So the negative sign doesn't make sense. So in this case, 8.1. When does it hit the ground? 8.1 seconds after I throw it. When is this used a lot? Baseball. When you hit it, where is it going to hit the ground? Missiles, you're throwing missiles. When does it hit the missile? The ground. Physics going to have fun with this. This is basically what they work with. Now, this is something for you to try. Balls propel vertical upward from the ground. Its distance in feet from the ground at t seconds is given by such formula. At what times would the ball be 30 32 feet from the ground. Now, in this case, you're going to have two answers, and they're both going to make sense. Now, why does this make sense? There's the ground. Let's say that's the ground. You throw an object, then it goes down, right? It's asking when is 32 feet from the ground. If I was to measure it, let's say this is 32 feet from the ground. Notice how I have 2 points that are 32 feet from the ground. It makes sense that I have two answers. All right, so let's read this part. Consumer price index. So those of you that are going into economics, business majors, you guys will be dealing with the consumer price index, which is abbreviated as CPI. It's used to measure the trends in prices for a basket of goods purchased by typical American families. This index used a base period from 1982 to 1984, which means that the index for that period is 100. The quadratic function defined by, and it gives us a function, approximates the CPI for the years 1980 to 2014, where X is the number of years that have elapsed since 1980. So for us to solve for a year, we're going to solve for X, and that X means how many after 1980. And once again, this is going to approximate it from 1980 to 2014. Okay. Now we're going to use such formula. Use the model to approximate the CPI for 2014. Okay, so remember my X was how many years after 1980. Now we want to approximate it for 2014. Now, how many years from 1980? I'm just going to subtract 2014 minus 1980. That gives me 34. So I know my X is 34. Now we're going to work this out. So I'm just going to say negative 0. We're going to call this f of 34 is equal to negative 0.002 times 34 squared plus 4.8 times 34 plus 83.7. Okay, let's work this out. My first term, I have to do exponents before I do multiplication. So let me go 34 times 34. I'm looking at this part. 34 times 34 is 1,156 times a negative 0.002. That is negative 2.312 plus 4.58 plus 34. Let's see, 4.58 times 34. That gives me 155.72 plus and it gives me 237.108. So we're going to abbreviate this to 237. The number after the decimal place is too small, right? 4 or less. So I ignore it. If it was 5 or more, I would have called this 238. Okay, so now, in what year did the CPI reach 200? So when is this 200? So what I have here it is 200 is equal to negative 0.002x squared plus 4.58x plus 83.7. Basically, when is this equal to 200? All right, I'm going to let the left side equal to 0. So let me subtract 200. So I have that 0 equals negative 0.002 002x squared plus 4.58x minus 116.3. My A is negative 0.002. My B is 4.58. And my C is negative 116.3. All right, I got to do my B squared minus 4AC. I'm doing 4.58 squared minus 4 times a negative 0.002 times a negative 116.3. Okay, so 4.58 squared minus 4 times a negative 0.002 times a negative 116.3. Remember, B squared minus 4AC. I'm thinking 4.58 squared gives me 20.9764. Now, these two negative signs make a positive sign, but there's still a third negative sign, so that's just a negative. 4 times 0.002 times 116.3, I get 0.9304. Now 20.9764 minus 0.9304 gives me 20.046. Have to get the square root of that. I'm not going to work that right now at the square root part. But at least when it comes to solve for x, I'm going to have my whole formula. Remember, my negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to have a negative 4.58 plus or minus the square root of 20.046 all over negative 0.004. Okay. Now, when I use my plus sign, I get, I type this on my calculator part by part, I get 25.7. Okay. Now, when I use the minus sign, I get 2,264.3. Remember, this thing is going to estimate how many years after 1980. Now, if I was to do 25.7, that is basically after 1980. 1980 plus 25, that means it happened in the year 2005. The 0.7, it's more like, that's like August the 12th. That's what 0.7 of a year it is. But year-wise is 2005. Now, 2264 plus 1980, that gives me a big number. Remember when we saw this formula, it says it's going to estimate it from 1980 to 2014. Anything after 2014 is just too far. That's an unreasonable year. But this other number is too much. So this thing is going to reach 200 in 2005.